Sorry, we are a little bit late, few minutes. I'm happy to introduce Doug Pettigan. Doug is an embedded systems engineer at a company based in Hamilton. It's called Nexus Networks Inc. He's been an instructor and has given several Arduino-related workshops. He has also some expertise in e-textiles. How do we go about building microelectronics and embedded and integrate into a wearable format? Today he's going to share some of his expertise in interfacing and integrating different components with Arduino. Please join me in welcoming Doug.
Okay, thanks for having me. I have to say, after reviewing the projects from this class for last year, I'm actually pretty intimidated. I'm not actually sure exactly what I can teach you guys. You seem to be pretty savvy when it comes to microcontrollers and Arduino. But I'll just try and give you a little bit of an overview on the different components, different types of networking, some do's and don'ts, and things that hopefully will help you get your prototype up and running for the trade show. So a little bit about myself. Like Suresh said, I do Arduino workshops. I've been working with electronics and embedded systems forever, but it's actually only recently, in the past few years, I've gotten more into Arduino, and I really like it. I do e-textiles work as well. I hold workshops on that, and I'm also doing a workshop at a conference in Hamilton called Function Keys, which is coming up in November. So I'll be doing an e-textiles workshop there as well. And okay, so let's get started. Okay, so just first off, I'm just going to do a little bit of review. So you probably already know most of this, but just bring everybody up to the same page. Typically, when we're dealing with networks that most people are familiar with, it's kind of a star type topology, meaning that you connect to a central hub or router, each device, laptop, phone. And from there, it connects up to another set of stars, basically forming a tree of star, which essentially is the internet. That's probably the most common type of network that you've encountered so far, topology-wise. Now, physically, if you've ever played with a router or switch, you plug all the cables in, you can kind of see how that's sort of the central thing. But with wireless networking, it's actually the same thing, but it's more on a logical level, that everything is hooked up in a star configuration. So what that practically means is that your laptop, even though you're sending a message to the person sitting next to you, it's not going directly to their laptop or phone. It's going up somewhere else, at least to a router, and then coming back down to their device. So it's always, and that's also called an infrastructure type network, meaning that there's networking equipment that everything hooks up to, as opposed to an ad hoc network, which we'll talk about in a little bit. So we're also going to be looking at mesh networks, and these are ad hoc networks that communicate to each other, different nodes side by side, and they're also called self-healing networks. And so that can be useful in situations where you want redundancy. If one transmission path goes down, you want to be able to keep the messages coming through. The ring topology is there, but nobody ever uses that anymore. That's like something really old called token ring, which probably nobody here has ever heard of. It's never used that much. Bus topologies aren't used that much anymore, except in certain serial type situations like RS-485, multi-trop in industrial networking. The point-to-point or line, the point-to-point or line is typically what a serial RS-232 or TTL level serial connection is. is directly connecting one computer to another. We can also do that actually with Wi-Fi. We can do that with Zigbee, and we can do that with Bluetooth, as we'll see as well. So the different transmission mediums that we're probably dealing with that we're familiar with are Ethernet, hardwired Ethernet, wireless or Wi-Fi, and serial. So if you played with the Arduinos, which I'm sure you already have, you're definitely familiar with serial over USB. That's how you communicate with the Arduino. And we'll actually be looking at serial over Bluetooth, serial over Wi-Fi, serial over Zigbee as well. That's pretty much how communications to and from Arduinos happens for the most part, is encapsulating the serial protocol over another transmission medium. So, just looking briefly at different sort of infrastructure and ad hoc. With infrastructure, you usually have fixed points of communications equipment that everything connects to and talks to. So if one device wants to talk to another, it has to go through that fixed piece of communications equipment, whether it's wireless or wired. Whereas in an ad hoc network, the devices talk to each other without the need for infrastructure. But typically, though, as we'll see a little bit with the Zigbee and mesh protocols, is one of these nodes in the ad hoc network will actually typically hook up to a fixed infrastructure point to get the information to somewhere else. And that's typically called a gateway device, not to necessarily be confused with a router. So, what's a network and a protocol or a protocol stack? It's just a layered collection of software that allows you to implement communications over a physical medium. I'm not going to go into this in depth. This is essentially the OSI model of networking, but I'll point out a few salient things. The physical layer is what we were talking about on the previous page. That's the part that's responsible for the actual electrical transmission of the bits through whatever medium, physical or wireless. And then the data link layer is what's responsible for actually ensuring those bits actually are correct and are getting through. So the Wi-Fi, serial, Ethernet is actually only really concerned with these two little bits here. And then up here, you have your TCP/IP, Internet Protocol, HTTP, and then up here, for instance, you'd have your web browser. So the important thing to understand is the way these models are built and implemented on computer systems is essentially the only thing that you need to know is the top layers really don't care what's happening at the bottom layers. So, for instance, we can easily replace this with TCP/IP over Bluetooth, and even though it would be much slower and have a lot higher latency, we could web browse with the right configuration using the same web browser that we're used to without noticing any real difference, simply because each layer is designed to interface with the layer above and below it, not in different parts of the model. So I'm not gonna really say much more about this, but except to also note that the data link layer is effectively what you would call the driver layer. Not quite, but and that's where on your laptop, on your phone, all this is pretty much done for you, even with the Bluetooth, like on your phone. The Bluetooth stack, everything is already implemented for you. But when we start to do this on the Arduino, well, that's where we have to start bringing in libraries and different things to actually implement the data link layer. And that could be several different libraries depending on what it is that we're trying do. So we're going to look at wireless, how to actually get the Arduino to connect over Wi-Fi, and that's actually, in some respects, the simplest thing to do. It's actually quite simple to set up the Arduino as a web server. And so that's useful if, in fact, you want to get your device, your application, directly onto the internet. Other options, if you're working with a cell phone, chances are you probably want to use Bluetooth. That would be the way to get data from. So you might have your sensors hooked up to the Arduino. You'd have a Bluetooth adapter or shield plugged into the Arduino, and you would use that to connect to your cell phone. And then from there, you'd have your application running on your cell phone, or you could just then take that information and forward it to somewhere else over TCP/IP, if that's what you so chose to do. We'll talk a little bit about mesh and Zigbee networks. They're a great option if you need to do telemetry over very long distances. Like with some of the Zigbee devices, you can get upwards of over 28 miles distance on a coin cell battery. So they're not cheap either. But for long distance telemetry, especially point to point, for very small, low power devices, Zigbee is very useful. Another technology that we'll briefly touch on is using cellular directly with the Arduino. You get with the appropriate SIM card, you can actually get your microcontroller directly onto a cell network, send text messages, and even do TCP/IP networking. So these little acronyms that I have here. So WLAN. So what we're talking about with a local area network, typically we're talking about something the size of this room. There's a wireless access point in here. Which then hooks up to other routers and things. But basically, with a local area network, with respect to Arduino networking, we're talking about something that's room size. With a WPAN or wireless personal area network, we're looking at something that's within the neighborhood of 10 meters, and practically usually less than that. So that's typically used for hooking up sensors to a device, and then from there, that device would act as a gateway and have Wi-Fi or cellular connectivity to then further get the data somewhere else. With the Zigbee networks, basically, depending on how they're configured, they can be anywhere from a wide area. They pretty much cover the whole gamut, from wide area network to personal area network. And cellular technology, if you have something that's on the move outside and you need to have a constant stream of data as opposed to, let's say, using a store and forward method by connecting your device up to a cell phone, then cellular GSM technology is pretty much the way you have to go with that. Okay. So inside of each wireless device, we have to remember that it's actually a radio, and as such, it has to be properly certified, FCC certification, but it operates in an unlicensed band called the Industrial, Scientific, and Medical Band. The typical frequency bands are 915. That's where you'll find some of the Zigbee Pro devices operate. Very common is the 2.45 megahertz band, and some in the 5.8 gigahertz band as well. And the thing is, and we'll see some pictures and we'll talk about the networking modules, typically most people, when they're doing prototyping, even in professional shops, they don't start with the bare networking chips. It's just too much hassle to design a board and get it working. They typically buy a module that's already pre-FCC certified. So anything that you buy for the Arduino is already going to be the chip, and the whole configuration will already be FCC certified. But you pay a lot more for that because the manufacturers of these modules have actually gone through the trouble of getting them FCC certified. But for prototyping and low production runs, it's actually worth the cost to use these pre-certified modules. If you get to the point where you're making 100,000 of them, well then, you'll pay an engineer to actually redesign your system to use the actual chip and integrate it into one board rather than using the module. Now, of course, since they're radios, we have to think of interference. Now, I'm not that well read on interference in terms of medical devices specifically, but I do understand that there are issues and can be issues with that. And so you really need to, at the get-go, think about where your actual device is going to be used and under what conditions, and keep that in mind as you select the type of networking device that you're going to use. As I'm sure a lot of people know, the 2.5 gigahertz Wi-Fi band is particularly noisy and problematic. There are a lot of different, even non-networking devices that operate in that band that can generate interference to your device, and you can also cause interference with your Wi-Fi device to other devices. But since it's an unlicensed band, pretty much you have to take it. That's the whole point of working in an unlicensed band. So you may want to roll that into your application design to understand that, connectivity is never perfect. Just because you have an internet connection now doesn't mean you'll have an internet connection, when you walk through that door. It just doesn't work that way, and I get really frustrated a lot of time because internet application designers just don't understand that always on is not always on. And it'd be really, really good if you keep that in mind and understand that think that your connection will drop. Assume that it will drop, assume that it will never be perfect, and I think you'll come up with a more robust, a better end user experience. So Bluetooth as well uses the same Wi-Fi band. In fact, uses sometimes in certain devices like your cell phone, uses the exact same antenna as Wi-Fi. So the two can, in certain circumstances, interfere with each other. And something new I just found out about is, and I don't know too much about it, but something to bear in mind is that there's some issues with proximity of Bluetooth devices to USB 3.0 cables. And it seems very real at this point. So if you have any of these devices and you're using Bluetooth and you're running into problems, you may want to bear that in mind. So the thing with, as you guys probably know more about this than me, but wavelengths. The longer your wavelengths, the harder it is for the wavelengths to penetrate fixed structures. So depending on the type of situation where you're going to be using the networking devices, if you're using Zigbee, you might want to choose a 900 megahertz Zigbee devices would work much better in a building like this than ones running at 2.45 megahertz, simply because of the fact that the longer wavelengths penetrate fixed structures better. However, of course, shorter wavelengths have a tendency will travel longer, can punch through smaller holes. So just something, it's probably for your prototype, it's not really going to matter that much, because maybe you're just doing a proof of concept to see that it'll actually work. An engineering prototype is an entirely different animal. But if there's any, I don't know if you have access to them in this course, but if you're running into any weird problems, an RF spectrum analyzer is really the way to go to troubleshoot these problems. Because you have to remember, at the very bottom level of this, it's still an analog problem. It's how to get these RF signals from one device to another, and it's only really at the application level that it's digital. So look at the different types of antennas that you might use with your networking devices. So this one right here, these are directional parabolic antenna. That's a Yagi antenna. These are very useful for long distance point-to-point applications. Is where you typically use that. You're probably not going to encounter that or need to use these for your particular applications, but I thought I would just point them out. There's also smaller directional antennas that are more suitable for indoor use as well. These are more outdoor antennas. But they do make the best use of the available transmit power, and they're great for point-to-point connections. But the most typical external antenna that you're going to see, of course everybody's seen this on their wireless routers, is the typical omnidirectional rubber duck type antenna. So it can be used for either point-to-point or multi-point connections, and they typically come with anywhere from 5 to 14 dB of gain. And right here, this is a reverse polarity SMA connection, and I'll talk about that a little bit further and why you might want to choose. This is probably one of the most important decisions you make when selecting a wireless module, is whether or not you want to use an onboard antenna or you need an external antenna. I generally choose myself networking devices that have at least the possibility of hooking up an external antenna, particularly if you're going to put it inside of a box or an enclosure. The onboard antennas really aren't going to do much for you, so you're going to want something with an external antenna connection. Okay. Now these are the other two most common types of antennas that you'll find on networking modules. PCB trace antenna, very common with Bluetooth, and a ceramic chip antenna as well. I'm not sure about the PCB trace antennas, but the game with the ceramic chip antennas, doesn't get much above 1 dBi, if that. A lot of networking modules will have a UFL connector, so you have the ability to plug in different types of antenna connections to this. This little device here is something that you can pick up. It's actually a UFL to reverse polarity SMA adapter, and so what you can do is it has a little nut here, so you can drill a hole on the side of your box. You can mount this, and then hook this up to here, and then you can plug in your rubber duck antenna or any other type of antenna that you want. So I tend to, depending again on the application, but I tend to like ones that have UFL connectors. And I don't know if anybody's here used the new Raspberry Pi 3. That's a huge mistake they made on it, was not putting the UFL connector. So I've been using them in industrial environments. They're great with that. We're making touchscreen interfaces for CNC machines. So I still have to use a USB dongle with an SMA connector because I need to pull the antenna outside of the enclosure. So it was a real pain to find something that was compatible with an SMA connector with the Raspberry Pi 3. So, for 2 seconds of engineering, they should have put it on. But hey, I'm not the Raspberry Pi guys. Okay, so let's talk about specifically Arduino Wi-Fi right now. Okay, so most of the Wi-Fi shields that support the Arduino only come with the B and G versions of Wi-Fi 802.11, which means they only run the 2.45 megahertz band. There are a couple, some of the newer ones are actually starting to support N, which means you could shift to the 5.8 gigahertz band to get away from some possible interference if that's what you wanted to do. Given the speeds that most Arduinos run at, particularly if it's an Uno or a Mega that you're putting the shield on, your actual bandwidth really isn't an issue. You're not going to be generating data fast enough to be concerned about how fast your actual Wi-Fi connection is. It's more a choice of whether or not you want to use the 2.45 or 5.8 gigahertz band. So, as far as I can tell, there's nothing in AC available for the Arduino, and there's really no necessary for anybody, I think, in my opinion, to develop that. So it will never happen. And of course, the networking equipment that you're going to be connecting up to, of course, they'll all support BG and N anyway, so it's really kind of irrelevant. There is an Ethernet shield available for the Raspberry Pi. So I'm not sure about here at the university, but in certain situations where I am, getting an actual Wi-Fi connection can be problematic simply because of the security restrictions that are in place. So sometimes prototyping, with an Ethernet shield and your own wireless router, create your own wireless hotspot, hook your laptop up to the wireless router, can actually be much more useful. You can do it. Sorry, I just said wireless router. Yeah, you can do it that way as well, or to just a hub or a switch. It's just your program that you write on the Arduino is not going to know the difference. It's just a matter of placing a call to the Ethernet library with the Wi-Fi library. It's pretty much the same as far as your program is concerned. What am I doing for time? Okay. All right. So as I was saying, the external antenna connectors, the UFL and reverse polarity SMA are not common, but they are available. And it typically interfaces using to a host device using SPI, the serial peripheral interface. So if you have another sensor or device that's going to be using SPI, that's something that you might want to take into consideration. But you can also interface using the built-in TTL serial. Some Wi-Fi devices have the ability to do that as well. So if you want to use the SPI bus for something else, get a Wi-Fi module that will interface to the Arduino over TTL serial. So I'm not going to run over the program, but if you go into the Arduino and you actually pull up the Wi-Fi web server code and you look at it, you'll be astonished at how simple it really is to actually set up a Wi-Fi server. The actual HTML code is like this much. It's actually quite astonishingly simple to do, and it's pretty straightforward reading through it. So you can do that with a Wi-Fi shield. This is a Wi-Fi shield from Adafruit. It's one of the ones I use. It doesn't have an external antenna connector, but it has a ceramic chip connector here. It also features a prototyping area here, which is useful. Some shields come with the prototyping area, some don't. This also comes with an SD card as well, so if you need an SD card as well as Wi-Fi for your application, this is a good choice. Again, some do come with the SD card, some don't. But the one big problem that you're going to run into if you're going to do a Wi-Fi web server on the Arduino is the library code takes up a lot of space. So on an Uno, over 75% of your program space is already gone, used up, if just by the Wi-Fi and SPI libraries. So if you're going to do this, it's probably better to use a Mega, Zero, or some other Arduino that has more program space. And the wireless shields consume a lot of power, so stable power supply is necessary. Otherwise, you're going to run into glitches on Wi-Fi. You might want to power the board, especially if you have a lot of sensors hooked up as well, using the external VIN connections here, or putting 5 volts in here rather than using a power adapter here, because the current's limited through, because you need this, 9 to 12, somewhere around 7 to 12 volts input, and I think the output of the voltage regulator down on the actual board is limited. So basically, you get Wi-Fi in a lot of different formats for the Arduino. I'll talk more about the XP format later. This is an Arduino MKR1000. This is an Atmel SAN chip with Wi-Fi built in. So, but it's Arduino compatible. So that could be, if you're going to want, it's actually much more powerful platform as well. So if you know you're going to be doing Wi-Fi, you may want to consider using a board like this. But if you want to stick to something that's more like an Uno, you can actually get Arduino Unos with built-in Wi-Fi as well. It's kind of hard to see, but there's a UFL connector right here. So there's lots of different choices. There's Google them, Arduino Wi-Fi or Arduino Wi-Fi, and you'll see that there's probably about a dozen different boards and configurations that are available. Okay, Bluetooth. Bluetooth comes in tons of different versions, but the two most common ones that are available for the Arduino are version 2.1 or Bluetooth Classic and version 4.0. Version 4.0 also encompasses something called Bluetooth Low Energy, which is a new standard for interfacing low power sensors over Bluetooth. The connections, unlike Wi-Fi, basically they're point to point with your gateway device. So unlike Wi-Fi, where you can talk to any other computer, once you're actually hooked up to something like the internet, you can talk to essentially any other computer. It's not the same with Bluetooth. You're only talking to the gateway device that your Bluetooth sensor connects to. It does use a star topology, but not the same as Wi-Fi. So, and with Bluetooth Classic, you can only talk up to 7 slave devices. Now, the thing, I'll go over this a little bit more on the next page, but a couple pages. But in terms of transmit power, they come in 3 different varieties, with class 2 devices being the most common. So as you can see, that's typically why it's called a personal area network. simply because 10 meters or 33 feet, well, I guess it's room size, but, you know, for practical purposes, you know, for most Bluetooth connections, you're not going to get much more than a distance from here to the end of the table. In my experience with standard class 2 devices, I don't have much experience with class 1 devices, but that might be an option if you want to use Bluetooth, but over a slightly longer distance. And I'll just mention that when you're going out and you're purchasing these devices, look really closely at what they actually do. You know, look at the specs of the module. You know, just for instance, just because it's Bluetooth 4.0 doesn't mean that it's going to do everything that you think it will. Because the Bluetooth 4.0 specification actually allows a device to be Bluetooth Classic or Bluetooth Low Energy or both. So if it calls itself Bluetooth 4.0, you know, you may end up with the wrong device. So read carefully exactly what different protocols and specifications that each device, and the same will apply to Zigbee as well. There's just a myriad of different versions, so you really need to look closely at what you're buying. So Bluetooth Low Energy. I don't know if anybody working with Bluetooth Low Energy that you're familiar with at all? Has anybody talked to you about using that?
There are quite a few tools that are using Bluetooth, but I'm not sure.
Low energy, yeah. Low energy, I'll just say this, Bluetooth Low Energy is much harder to work with in terms of programming wise. You need a whole set of APIs like if you're going to write an Android program that interacts with Bluetooth Low Energy as opposed to Bluetooth Classic. So it's not, and the thing is, to be Bluetooth Low Energy basically means, you know, means your whole device should be low energy. But I mean, if you plug in a Bluetooth Low Energy adapter to your Raspberry Pi, well, that's not really low energy anymore, is it? So typically, what we're talking about Bluetooth Low Energy devices are usually microprocessors that have the Bluetooth Low Energy radio actually integrated onto them. And this is an example. This is a sensor tag from Texas Instruments. It's a microprocessor with Bluetooth Low Energy. It runs off of a tiny coin cell and has about 15 different sensors. And this hooks up to my cell phone with Bluetooth Low Energy. And there's an application on there that acts as a gateway that gathers the data and then packages it into a protocol called MQTT. And then I can access that information over the internet through the IBM Watson IoT Cloud. So typically, Bluetooth Low Energy is the realm of really small dedicated microcontrollers with Bluetooth. Now, that's not to say that, you know, if you want your, if that's what your application is eventually going to become, but for prototyping purposes, you can just as easily use Bluetooth Classic to demonstrate what your application is going to do without going through the hassles of engineering and dealing with Bluetooth Low Energy. So to do Bluetooth on an Arduino, the simplest thing is, again, typical shield. You notice in this case here, it's actually not using SPI. The interface to the Bluetooth module with the PCB trace antenna is actually through one of the Arduino serial ports. And in fact, we call it a modem because you actually configure it using an AT command set. So you simply send an ASCII string with AT commands that configure the Bluetooth modem. And when you pair this with another Bluetooth device, whether it be your phone or a computer, it'll show up as a serial port. So everybody knows, should know how to work with serial with programming. So it just becomes a matter of sending ASCII strings back and forth between the two devices. Now, there is a couple of caveats, and one of them is, of course, serial port profiles, which is what you need, which is the networking stack that you need to implement this, is not available on iOS, of course, which means you have to use, if you want your application to work with an iOS device, you'll have to learn how to implement the Bluetooth low energy stack in iOS, and good luck. It's not easy. So again, not all version 4.0 devices will implement the serial port profile as well. So look closely. Probably version 2.1 devices are probably probably the most common to find for Arduino, and what you want to use. And also, because you're dealing with serial as well, this is something to remember, is you can easily prototype your application just using a serial connection between your host computer and the Raspberry and the Arduino, and you don't even really have to worry about the Bluetooth shield, and you can just add that on later. So it can make it easier without dealing with the networking issues to actually get your algorithms and your actually base application up and running if you build from a serial, think building from serial up and then just adding the serial connection on top of that. How am I doing? Okay. All right. Okay. So we won't get to. And I apologize. It's really hard to find this building. Nobody knows what this is called, the Power Building. No. Okay. Just the Bluetooth shields and modules. There's a lot of different variety. They come in the XB form factor that I was talking about, which I really like. They come in modules like this as well, so you can put some connectors on there. They're also available for the LilyPad as well. This is a Bluetooth low energy module for LilyPad, so if you're doing wearables, you can incorporate that in there as well. And also there's Unos that have the Bluetooth built in. Here's a ceramic chip antenna. So maybe just go to this here, just something. Zigbee, if you're confused, Zigbee is a wireless networking protocol. XB is the actual form factor. There's a lot of XB devices out there that aren't Zigbee. Like there's Bluetooth, Wi-Fi devices as well that plug in to this form factor, which then you can access over serial as well. Okay, maybe I'll just, if there's any questions.
Quick questions. Maybe one question. Students have ordered most of the prototypes. Are there any shops in Hamilton or Cambridge area where they could quickly buy?
Right. Okay. Yes. Online? Yes. That's important. Well, you got a couple of options. Basically, say Allen in Mississauga. If you're looking for electronic, I'll send you a complete list, and then you can forward that. But I'll just quickly talk about a couple of things. So, say Allen, Mississauga for basic electronic components, some Arduino stuff. Your best bet if you want to drive somewhere, buy something, is you have to be Creatron in Toronto. They're on College Street, and also right across from them. Believe it or not, one of the best places to buy electronics, basic resistors, capacitors, switches, LEDs, and connectors is Home Hardware. For some reason, the basement of that particular Home Hardware has just been electronics mecca forever. So those two places there are really good. AliExpress is a great place to get stuff cheap, but right now with the time frames, and I've run into the same problem myself with the time frames that you're dealing with, you'll end up with disappointment if you try and buy anything right now from for your project from AliExpress. I wouldn't even consider it. And recently, over the past couple of years, there's some great Canadian online retailers as well, so you don't have to deal with U.S. shipping and customs too. So you can get stuff within within a few days. Canada Robotics in Markham is a good one. Buy a Pie for Pie stuff there in Ottawa. You can get stuff through Canada Post shipping in a few days. So there's lots of good options. I'll send the complete list to Suresh and you can forward that to you.